So in this video, I want to show you how we can use the TI-84 and StatCrunch to perform a test for independence. So we're looking at the same problem that we just did by hand in the previous video, but I'm going to show you how we can use our calculator to do the test for independence. So if I bring in my TI calculator, first of all, when we have a test for independence, we're going to enter the information from our contingency table into a matrix. So the matrix button is right here. So I'm going to go to Second and Matrix, and I'm going to enter a matrix of this data. So the way I do that is I'm going to go to Edit, and I'm going to select a matrix. And so we're going to first of all have to enter the order or the dimensions of our matrix. And so the rows go first and the columns go second. So in this case, we have 3 rows and 3 columns. So again, rows first, columns second. In this case, it doesn't matter because we have the same number. But if we had, say, 4 rows and 3 columns, the 4 goes first. Now I'm going to enter my data into this matrix. So 593, 26, 33, 64, 8, 11, 169, 19, 16. So I have my data entered into this 3 by 3 matrix. Now I'm going to go second and quit to go back to the home screen. So I've entered my data. Normally we've been entering our data into lists. For a test of independence, we do not enter the data into a list. We have to enter it into a matrix because it's a contingency table. So now that I have that entered, I'm going to go to Stat and Test. And we are going to use a chi-square test. So I'm going to scroll down on my calculator. It's option C. So that is a chi-square test. Now, all I have to do is tell the calculator where I put the data, where I put the observed data. And that is in this matrix called Matrix A. Now, on my calculator, the way it's set up, the calculator is going to calculate the expected values, and it's going to store those expected values in matrix B. So I don't have to find the expected values. The calculator is going to do that and put them in matrix B for me. So if I say calculate, my calculator calculates the chi-square test statistic, and so it gets 21.357. Now when we did it by hand, we got 21.356, but we have actually a little bit of error because we rounded these expected values. The calculator didn't round as much as we did, so it got a more accurate answer. Although 1,000th is not anything to be concerned about. The calculator also gives us the p-value, so 2.689 times 10 to the negative 4. So again, that's scientific notation like we obtained previously. Now when we did this by hand, we got 0.0004, so we have a little bit of discrepancy, but not anything too terrible to worry about. Here we would get 0.0003 if we round to 3 places, so we're off by about 1/10,000. So again, the calculator will find both the test statistic and the p-value for us. Notice it also finds the degrees of freedom, which is 4, which we noticed as well. Now if I go to matrix and look now at matrix B has the expected values, and so 573.54, 73.012, and so on. And we calculated those previously, so I'll pull that back in just to compare. So again, we calculated by hand 573.538, 36.801, 41.661, and so on. So our expected values agree with the calculator's expected values, just for the sake of pointing that out. So obviously the calculator does that work much quicker than we can do it by hand. Now if we look in StatCrunch, I've already entered our information into StatCrunch. So I have our information in columns, and the first column is giving the row labels, which is the wantedness of pregnancy. So to do a test for independence in StatCrunch, I'm going to go to Stat, and I'm going to go to Tables. In this case, we have a contingency table and we have summary information, so with summary. I'm going to select the columns, which are the less than 3 months, the 3 to 5 months, and the more than 5 months or never. So I'm selecting those. My row labels are in the column called wantedness of pregnancy. Now, if you will notice right here, we have options for hypothesis test. I can select a chi-square test for independence. And when I select that and say compute, StatCrunch returns this information for me. Notice right here at the bottom, we have 4 degrees of freedom. Our value, which is our chi-square test statistic, is 21.357, which agrees with our by hand and with our calculator result. And the p-value is 0.0003, which agrees with our calculator result. Now, if we would have wanted, we could also have calculated the expected values. So if we look right here, when I was selecting the chi-square test for independence, in the window above that, I could select expected counts. Had I done that, it would give us the expected counts as well in our table. So here we get the 573.54, the 73.01, and so on that we got both by hand and with the calculator in the second matrix. So we could obtain those as well. So again, this is how we can conduct a test for independence in StatCrunch. So you can see, using the technology, using both the calculator and StatCrunch, the results are calculated much more quickly than we can do them by hand. So I would highly recommend that you want to learn to use your calculator and StatCrunch for this purpose.